All right, now this is probably the most deadly earthquake hazard there is. Now, um, this will affect human habitation as well as all natural habitation. So this would equally affect, not just because humans have built stone houses or because we put pipelines through things. This is going to be an extreme threat. So if you didn't already write this down from the last video, I know I paused or ended on this, but you should write it down now. So basically, tsunamis, they can be created from large landslides, but most commonly they are created from earthquakes that rupture the ocean floor. Now, earthquakes below a 6.0 don't typically rupture the ground surface. Something slips or something bends in the earth due to these tensile forces, these lateral forces, these compressional forces. But until you have about a 6.0 earthquake, it's not enough to actually break or crack or rupture the ground surface and give us a fault scarp. So this is what we're having when we have a tsunami. We're basically having the entire ground surface in the ocean slip. We've got a fault scarp created. Now, fault scarp can create a tsunami anywhere from like an inch to a couple foot fault scarp. Now, there's a place in your notes on the next page, I think page 21 of your notes, to write in this diagram of a tsunami. But first, don't write what I'm going to write. I'm going to show you why a tsunami is so dangerous. So if we've got the ocean floor here, and we've got water here, and we're way out in the ocean, so I'm not going to draw a water surface or anything there. And again, you don't need to draw this part. So what we have here is we have, what is this part called? Anybody remember what this part in the earth is where this, I'm not even going to tell you what that is because I'm going to tell you what that is. I'm going to ask you for that in a minute. This is called the focus. This is where the earthquake occurs. This is the fault plane. So we've got forces, and since I'll just make up whatever this is, I'll say we have tensile forces. Forces pulling these two sides of the rock apart. Something slips, we have a jolt, we've got this ground surface dropping. So I've got this ground surface, now this is the new surface. So what I've created here is a fault scarp. Now a fault scarp wouldn't normally bother anything, make the mountains a little bit taller, but what we've got here, if you haven't seen this, I'm going to see if I can switch colors, is this ground surface will drop, and it will drop really, really, really quickly. And when that does, the entire water column from the surface of the ocean to that drop basically moves. So we've got normal waves of the ocean. Now, normal waves of the ocean are only affected by wind. So when we have waves on the ocean, you get a little bit of waves here, a little bit of waves here, and then the wave actually diminishes the deeper you go in the ocean. Water down here does not get affected by the surface waves. But when we have a drop from an earthquake, what we have is we have the entire column of water of the ocean dropping down. If it's an inch, it drops an inch. If it drops 2 feet, it drops 2 feet. So now we've got basically a wave that started in the ocean due to this dropping water. Now, why a tsunami is so dangerous is because this wave will increase in height as it reaches the shore. So here, if you're out in the ocean and an earthquake happens below you and you're a boat floating here, let's say, okay, sure, we got a sailboat going here. This sailboat's going to feel a little bit of wave. It's not even going to feel anything different, most likely, depending on the earthquake, than the waves that are already moving that boat along. In fact, it could be as little as an inch wave and still cause a tsunami. So let's diagram that out and let's figure out why that is. All right, so we've got a problem. The entire ocean is moving in a wave. But this energy is pushing off the bottom and coming up, pushing out the bottom and coming up, pushing out the bottom and coming up. When we get closer to the land, so in the ocean, for most of the ocean, we actually have a very flat surface. We call them the abyssal plains. And then when you come up to a continent, what you have is you have a continental rise, and then let's say Jimmy's here having a good day at the beach. And he's happy because he's ignorant. He doesn't know what a tsunami is, and he doesn't know he's going to die soon. So what we have is we have this low-level wave that's the entire water column coming, and as it starts to come to the shore, it runs out of space to be pushing off the bottom. So we've got the water keep pushing off the bottom, pushing off the bottom, pushing off the bottom. But now, instead of pushing off the bottom for 300 feet, we are now pushing off the bottom in the shore here. And so what we get is we get this entire wave that keeps increasing in amplitude due to the decrease in the depth of the ocean here at the shore. So I might put here increase in amplitude due to decreasing depth near shore. Now, a lot of people think of a tsunami as being a giant cresting wave coming at you and it just takes everybody out. But what really is what we have is it's more of like, I've drawn it really short here because there's not enough paper in the world to draw this right. But basically it's like a massive long wavelength. And so what it seems more like is when a tsunami is coming in, first thing that happens is all the water just leaves the shore. Because as this wave's getting increasing in height, increasing in amplitude, due to the decrease in this depth out in the ocean, it needs to keep bringing more water and more water to get higher and higher. So actually the first thing you see on the beach is a quick receding of all the water off the beach. Just completely leaves. Do you see that? You're at a beach, run. Run to high ground. And then what comes in, the wave starts coming in, it's more like high water. It's coming in fast. It's more like a giant river flood that's just flooding the entire city really, really quickly from the ocean. And eventually it just rises and rises and rises until sometimes it can reach 30 meters high. All right, so here I have actually a documentary in here. I'm going to send the link to your parents. If you would like to watch that documentary, it's about the tsunami that occurred in the Indian Ocean. It was in, 2004. It hit many, many different nations. A lot of people died, but it kind of talks about what happened there, and you can actually see what a real tsunami is. There's a lot of real footage from that tsunami. So if you're interested, there is a documentary here embedded in my presentation. And again, I told you I'm going to send your parents the link for the video if they think it's appropriate for you to watch. You go ahead and watch it. Now it is PG-13, not PG-13. Sorry, it is PG. Sorry, my bad. Because it's a documentary. Because documentaries get in that lower rating, but there is a lot of death. There is a lot of emotional stuff there, and it's all real. So again, I'm going to leave that up to your parents to decide whether or not they want to show you that. But we will not watch it in class. We just don't have the time for that. Now here, this list I have here are the top 10 tsunamis of recorded history. So there could have been a larger tsunami, and there was. When the dinosaurs died, there was a massive tsunami. But right here, we have in 1771, Japan lost 12,000 lives due to a tsunami. 2011, number 9, again in Japan, 15,000, almost 16,000 lives. 1960 in Chile, 6,000 lives lost. Number 7 on our list in 1869, again Japan, 27,000 lives lost. 1707, again Japan. Now you're seeing a recurring thing: Japan, Japan, Japan. One of those reasons, think about it, why would Japan be receiving so many tsunamis? Why would they have so many issues with tsunamis? Why would they have so many earthquakes in the ocean? Number 1, they're an island in the ocean. Number 2, think about where Japan is. What kind of boundary is Japan sitting on? What's right next to Japan? What's going on at that location that would cause those earthquakes to happen all the time? Now remember, the island of Japan was created through a subducted plate, melting, rising magma, and created that island there. And so they constantly have earthquakes going on in that region. All right, Indonesia, 1883. Don't know what kind of Richter scale magnitude this was, but it did wipe out the entire island of Krakatoa. 40,000 lives lost. 1782, in the South China Sea, we lost 40,000 lives. Now remember, this isn't an instant. This is in one day, primarily for almost all these lives. Very, very quickly. Top third one, 1755, 9.0 earthquake in Portugal. Lost 60,000, and Morocco, sorry. 60,000 to 100,000 lives lost. 1908, 7.1 earthquake off the coast of Italy. Lost somewhere between 100,000 and 200,000 lives. 2004. Now this is the one the documentary is about. 9.1 earthquake hit in the ocean. Tsunami came, hit parts of Indonesia. Hit so hard of an earthquake that actually altered the wobbling of the axis of the Earth. 283,000 lives are estimated to have been lost due to this. The waves were so high on the tsunami that in the worst part, the deepest parts on land, the waves actually hit 50 meters high. So this tsunami, this was one of probably the worst maybe that we have had in recorded, and sorry, not recorded history, but in looking at evidence around the Earth, this was probably one of the worst ones that we've seen. And then, yeah, just due to an earthquake in the ocean. All right, sorry, we already did the diagram. We're good with that. All right, so recap. These are the questions you want to ask yourself, and I'll ask them in class again too, so don't forget this. So number 1, what's the focus of an earthquake? Be able to answer that question. What is the point on the surface directly above the focus? What are faults? What are 3 fault types? I'm going to have you guys draw them on the board. You have to produce them. And on Earth, what do earthquakes mainly affect? Name 6 of the earthquake hazards and be able to explain to me how tsunamis happened. Maybe we can talk about that again. I didn't do the best explanation on this video. All right, that's all for this video. We'll talk about volcanic hazards in the next video.